So welcome everybody. Thanks for joining us again. Yeah, I had a little bit trouble with my computer. That's why I'm just switching between terminals, but here we are and this is working. So happy and welcome Alex and Han today for today's episode. Welcome guys.
Hopefully thanks, it's great to be here.
Great to be here. Yeah.
Awesome. Let me just get to know you a little bit better. Han, what are you doing on your daily basis?
Oh, writing code. I manage the company.
Okay. What kind of company is it?
Yeah, so I'm the founder and the CEO of Jina AI. So we're a neural research company that founded in last year in February during pandemic. And so right now we have grown to 35 people all over the world, 3 offices, headquartered in Berlin, and then have an office in Beijing and another office in Shenzhen. So we are pretty diverse in terms of people. So like from Europe, from China, from India, from North America, yeah.
Cool. So you basically got into relationship during Corona, right?
Yeah, exactly. Yeah.
So how did you come up with that idea?
That all comes from my, kind of related to my previous job where I work as an engineer lead at Tencent. So Tencent is a big internet company in China. So when I work at Tencent between 2018 to 2020, so I was an engineering lead working on the search infrastructure behind WeChat. So WeChat is like a social app, very popular in Asia countries. And back in the days, the search infra was built on top of Elasticsearch. And it was built in a way that we have to, let's say, develop a lot of plugins on top of the search infra. So there's one plugin for image search, one plugin for long text search, one plugin for short text search. So over years, over time, so this plugins becomes unmaintainable, right? So it's like there is another plugin of plugins, right? So it's like multiple layers of plugins. So in the end, it becomes unmaintainable, but it's legacy infrastructure. So nobody wants to really touch it or really want to, refactor it. And so it was going in that way for many years at Tencent. And so when I joined the Tencent AI lab, right? So I was doing just like every new guy, every newbie who joined the company, right? So try to destroy their code, try to destroy the legacy infrastructure because you are great and all the others are just just stupid, right? So it's just like every engineer thing in this way. And so what I was trying to do, I led a team there, building using deep learning as kind of the building block, right, to re-innovate the search infrastructure bottom up. Right? So that was the idea, right? So people, some of you may know that deep learning, representation learning, this can somehow you can somehow convert something into a vector and then you compute the cosine distance. And isn't that it, right? Isn't that simple? Isn't that the search problem is solved, right? It's checked marked. Actually, it's not, right? So if you think about the search pipeline, it's a super long, super complicated pipeline, right? So you have the pre-processing, you have the indexing, you have the storage, you have the ranking, you have the aggregating, you have applying business rule and re-ranking, and then you have to incorporate the feedback loop, right? And then retrain the whole pipeline, right? So all these kind of things let's say a perfect search system, right, can only be perfect if you make every component perfect, right? And so therefore, if you think about deep learning's role in this whole pipeline, right, it's not only about just encoding something into vectors. It also not about just retrieval something and using cosine, to compute the distance or similarities there, right? Basically, our idea back in the days is to use deep learning in a very radical way, right? In a very radical way. in the sense that we just try to use deep learning wherever we can, right? So in every places, from pre-processing, from upstream pre-processing to the downstream ranking aggregating, right? So that was the that was an open source project back in Tencent in 2019, and then you still can find this project on GitHub, but it's archived. It's called a generic neural elastic search, which is a pretty ambitious name, right? Genus. And so that's kind of the father of today's Gina, right? So you can see from the pronunciation, there are some connections, right? Genus and then Gina. This kind of like a Genus is the father of Gina today, right?
Yeah, and genius goes in the bottle, right?
Yeah, no, not about it. I mean, there is a long story between of the genus name, which I can put into the next episode, right? But anyway, so and back in the days, Tencent. So back in the day, so that was a Genus project. But why I left Tencent and then jump out and doing this business as a startup, because in 2019 in October, this project was shutting down, right? So it was sunset. It was sunset because of the, back in the days, Tencent was facing a very intense competition from TikTok, from the ByteDance, basically the mother company behind TikTok.
Yeah.
And so the company decides to spend more energy and more human resources into video intelligence, right? Into video intelligence, instead of building a common universal search infra for every modality, for every data type, right? So that decision basically says that the marks the death of Genus project. And then because back in the day, back in 2019, I was so deeply involved in this neural search landscape, and I also very committed to open source projects. For some of you may know that. So I'm the creator of Fashion-MNIST dataset, which is a very common machine learning dataset nowadays. And also I'm also the creator of BERT-as-service. So the first BERT library, right after 1 month after the Google released BERT. So that was in 2018 October, right? But anyway, because of my dedication to open source and neural search, and then I think about the whole landscape, right? So I think about whether this is something that I have to do with in or without, with or without Tencent, right? And so luckily, by the time there are some investors just come to me, and we got investment from the day one, and we just I just jump out from Tencent and then just push this direction forward. That's kind of the origin story of Gina. Yeah.
Interesting. I guess the Tencent just had to close down because they had in mind that you have to do the Gina thing. And okay, otherwise this guy would not leave, would still do the job here. Let's get him out. But you're not alone, as I can see. So you have brought someone with you. Alex, hi.
Hello there. It's great to be here. As I said once before, but I have the memory of a goldfish.
Okay, so it's 7 seconds, as we know, right?
Something like that. Ask me in 8.
I can see one comment in the chat from Yuding, which says, like your fancy glasses. I guess this was targeting you, yeah, looking at your glasses.
Oh, I thought they were targeting Han, yeah, with his awesome glasses, or you.
Well, a more crazy one, definitely yours. So what are you doing at Gina?
So I'm Gina's DevRel lead, in charge of developer relations. Han and the engineers build all the cool code, and I mean it is, yeah, I can say it. It's past 6 p.m. here. I can say it. It's sexy code. It's doing really cool stuff, and I make it super sexy to the community. Yeah, so
this is sexy.
That's what we're all about.
Okay, so you're actually driving the community crazy, right? In some ways.
That's correct. Yeah. Doing a lot of community events, a lot of outreach, improving the onboarding process, making it easier for people to build a search engine for any kind of data.
Okay, cool. Yeah, thanks to have you here on the panel as well. But as I know that Han is going to present, right, Han?
That's correct. Yeah.
Fine, awesome. So I'm really amazed by your history, your business career and academic career, and what you have been doing here. That sounds like a huge, treasure of expertise. So let's try to dig deeper into what you have to show. And I'm really curious to learn more about neural search, to be honest. As you said, so search has been a long time accompany me in my jobs. So it was always kind of a challenge to get a good search running. But maybe you can help us to understand what's different with neural search in contrast to other kinds of searches and elastic searches, as you said.
Yeah. Yeah, cool. So so let me just share my screen and then let's kick off the presentation. And so we can have some chit chat or some question answering session at the end or in between, right?
Exactly.
And,
sorry to say that for everyone who just joined, you might find a Q&A section in the navigation bar. Just have a look. This is the area where you can place your questions. Since Han will take care of this presentation, just giving us the insights we're looking for, I'm looking for what you are actually asking and trying to put the questions in the presentation and during the presentation. So we don't wait until the end if it fits. And we're just watching him and ask him whatever makes sense. So use the Q&A section and thanks for being here. Okay, Han, sorry for the interruption.
Yeah, no problem. Okay, so now I'm officially start my story of Gina, right? So today, our main character, our main role is talking about this Gina, the open source framework that we built, and it's also very popular on GitHub. So if you go to GitHub/Gina-AI Gina, and then you see there's like a 11,000 stars repository, and this is the the main character that we are going to talk about today. A little bit of our company, this is not a personal project, it's not a hobby project. I always say that, there are three kinds of persons who are doing open source. The first type is doing open source as a hobby, and so you have a very decent work on daily basis, and then after work, you go back to your home and you have some spare time and you do open source things. So that's the first type. And then the second type is you work in a big tech giant like Google, Microsoft, you work in TensorFlow, PyTorch team, building the open source there. And the third one is, the guys who like me, who very passionate about open source, who believe open source, not just a spirit, but, a new economy, right? A stakeholder economy, right? So guys like me have to worry about, whether our strategy can really make people, let's say, put their bread on their table, right? So so one mistake that we made on community, on strategy, we could lose our job. The company could go bankrupt, right? So this is a huge difference from the doing open source as a business versus doing open source as a hobby. Anyway, so so we are big team at the moment, so we're continuous growing, right? So and the company will have some very good news, in the next couple of months, and we will expand even more, right? And so today's I want to talk about Gina from this in this three chapters, right? So I don't know how many of you have the background of neural search and cloud native, because those are the two keywords that we, that's describe Gina, right? So I want to start talking about neural search in general and also cloud native, right? So let's get some ideas. Why these two things? One is very AI driven, right? So one is neural search is very AI related. And the cloud native seems very like engineering things, right? So something that most of the data scientists won't touch. It's like it's not my job, right? So how can we marry these two words together, right? So that's the first question I want to answer, right? And the second question I want to explain is the design of Gina. Why do we need such system, right? Why do we need such framework? Why can't we just use Elastic and some plugins, right? So just like what we did in Tencent, why can't we just be like that, right? So Why can't we use some legacy pattern to solve a new problem, right? And finally, let's go into some, Jina in action. Let's look at how to use Jina in practice. Right? Okay. So let's first talk about the first question, right? It's the beginning of everything, right? So what is neural search, right? Before we jump into, deep dive into this question, let's just warm up. Let's just have some warm-up quiz. Think about this problem. Think about this as a.
Just could just for short, if you change the slide, I'm still on the about Gina slide.
Oh, really?
20. So
let me share the screen again. So let me reshare the screen. So I think there is something wrong with the.
I saw the Fashion-MNIST slide before, and I can see it now.
How about now?
We will find similar fashion items. Yes.
Okay. Yeah. Cool. So yeah. So let's start with this warm-up quiz, right? So finding similar fashion items among this database. Well, let's consider this as an interview question, right? So let's say the interviewer saying that we have a database of 60,000 fashion items, right? Fashion articles like trousers, shirts, long and short shirt, shoes, all this kind of things, right? And so they are articles, but they are also like they have an image, right? And then they also have some meta information such as the price, brand, the size, the color, all this kind of things, right? And then your goal, your problem is to given a photo, right? Given an image, so it could be like taken from your cell phone or uploaded from your computer, but nevertheless, the input is an image, right? And your goal is to find the most similar items, with respect to that image, right? So let's say top 100 or top 50, right? Right. So this is a super old, classic, cliche problem in e-commerce scenario, right? So let's say everybody should know, this kind of problem exists, right? It's not something made up, right? I made up, right? And I'm putting these things here because it is so classic that you can immediately recognize that, oh, I probably need to use deep learning to solve this, right? And you want to use TensorFlow or PyTorch to extract the pattern from the images, and then compare this pattern to the patterns in your query image, and then compute some similarity, right? And so this is exactly the problem of neural search, right? So you can see that you have neural network, and then you're trying to do a search problem, right? Trying to solve a search problem, right? So that's neural search, right? But just to let you know that this problem exists since 1970s, right? So back in the days where we don't have deep learning things, we can use simple heuristics to solve something, right? So don't over-engineer it if you don't have to, right? If you don't need to, right? Okay, so image search, right? Very classic search problem, neural search problem. Okay, now let's move on to the next level, right? So how about mesh? How about 3D mesh data? How to search something like that, right? So let's say I don't know how many of you play 3D games. I believe you all play, right? So that's not a question, right? So you may wonder, how this game is developed, right? Actually, most of people using Unity, right, to develop this 3D game, right? So the user journey, or let's say the developer journey of developing a game in Unity is often like you have an asset pool, right? So basically those monsters, video effects, audio effects, those are considered, this is termed as asset, game asset, right? And you have an asset store or asset pool, right? So you want to, and then you have a game scene. The game scene could be, just a grassland, a mountain, a village, right? A small village, indoor of your house, right? So what you want to do is you drag asset from your asset store into the scene, right? Drag asset into the scene. And then immediately you realize that, oh, this is so empty. The scene is so empty because there's nothing there, right? So you wish to have some functionality saying that, oh, how about right click on the asset that just drag into the scene? How about just right click on that and then pop us a menu saying that founding look like or fill the scene automatically. Found a kind of like a more or less a similar asset and then fill into the scene. Right? It could be a similar asset. It could be some asset is more like a frequently co-occurred in such scene. Right. So for example, if you drag a dinosaur into your house, you probably also want to add other monsters like zombies into the scene, and then probably skeleton, skeleton king, all this kind of things into your scene. And beyond that, right, it's not only about 3D mesh. 3D mesh is just one type of data in the game assets, right? So there could be video effect, special effect, which is described in particle functions, all this kind of things. And there could be sound effect, right? So this can be also associated. And so this is the problem that you cannot use simple heuristic to solve that. So let me tell you how people solve that in the right now in the game industry, in game developing industry, right? By file naming. So if you look at the assets of their game asset store, right? So every asset has a super long file name, which is concatenated by a lot of dash or underscore, right? So basically this, and then you can imagine that they use this file name as a tag to, as a kind of label for easy people to search, right? And so when people search, they're basically searching for file name, right? And then that's how people, that's how the game industry, all the game entity game developing tools majorly work with, right? But if you think about it, we can use deep learning to represent every object, every asset, whether it is an audio effect or whether it is 3D mesh data, you can always transform into a universal representation and then search over this universal representation, right? So that will solve a lot of problems, right? So that's another example of neural search. Okay, so finally, our good old chatbot, right? So it's like a Turing test from even early days, right? I put these things here because I want to tell you that a lot of neural search problem does not necessarily have a search box, right? So this is super important. The neural search applications in the future, I believe, will not be, this kind of search box restricted. Right. So you can imagine right now, you can think about, right? So the found and replace functionalities in the app, in the software, right? Basically, every time you open an app, whether it is a mobile app or your daily word processor, IDE, PyCharm, all this kind of thing, nearly every software has a basic functionality. It's Control F, Control R, or Command F, Command R, which is basically found and replace. If you found a software or app that doesn't have this functionality, then you say, okay, so this is just half done, right? So this software is not done. It's a alpha or beta version. It doesn't even support found and replace, such basic functionalities, right? So I believe in the 5 years, right? I believe in 5 years, neural search will become as common as found and replace as today, right? So you never really think about the, how do I support this found and replace? It's just such common infrastructure technology that everybody will use. Every app, will use. Right? And just to point it here, just back to the topic of question answering chatbot, the human-computer interaction things. My point here is, first of all, not all neural search apps has a search box, right? In the future, a lot of neural search high-level applications, the interaction between human and those applications is not through a search box, right? It could be via, speech recognition, voice command. It could be via, the special glass that Alex wearing, right? VR, AR, this kind of things, right? And so don't restrict your imagination about neural search. There could be a lot of very fun applications, right? So I was recently reading some news about the hype on NFT, right? Non-fungible tokens, right? Non-fungible tokens, right? So how about searching NFT using neural search? So that's something, right? So digital collections, this can be also searched by neural search. Right? Okay.
Question, because you say in this slide you say answer arbitrary questions in a closed domain. The closed domain, what's interesting in arbitrary questions also. Since we have discussed question and answer systems a little bit in the past with language models like GPT.
Yeah.
And we had some startup from the US, from also Ort, explaining that their approach as well. I would like to know a little bit more about what's the difference between language models in this case, and how does an answer like you show here, no, there's no evidence, well, companion animals or pets, blah, blah, blah. How does such answers come up? Is some kind of text generation behind it, or is it just finding text which might be an appropriate answer? How does it work?
Yeah, so when we talk about machine learning, or let's say non-machine learning, machine learning is too general. When we talk about the search or chatbot experience, chatbot technology, there are always like two types of technology, right? Two families of technology. So one is generation based, one is like a retrieval based. Then here we are talking about retrieval based, where basically the answer is not generated on the fly. It's basically their predefined answer. You just have to extract it. You just have to mine them from the database, right? And then the question answering, the chatbot, this kind of experience, underneath it is a mapping. It is basically searching question to question and then map the question to answer, right? Or you can directly searching question and answer, basically by mapping these two things into one, let's say, vector space, right? So these are the retrieval-based method. On the other hand, the generation method doesn't think in this way. The generation method basically says that like GPT-3, right? They learn, they are trained on large corpus, so they have seen everything, right? So they have seen everything, been there, done that, right? They have seen everything, right? So every time you ask a question, right, they basically use a language model and then try to complete your question with, with under certain constraint. And this constraint should be, the complete sentence should not be a question anymore. It should be, just an explanation of your question, right? With such constraint, right? And because of, this GPT-3 is, this generation measure is usually trained on super large corpus. So it has been, nearly every combinations of the base combination and also basic syntax, basic grammar, there's a next token prediction. All of this knowledge has been squeezed, compressed into this model, right? So that's why the model can generate such things. The difference between these two things is, let's say, when we build it really depends on where do you want to deploy such chatbot, right? So let's say in the customer service, I actually have a very good example, which I will show you. It's our document website. There is a doc bot that powered by Gina. And then you can search, you can ask questions about Gina's, all this documentation related question, and it will answer you and give you the snippet that, that somehow pointed to the answer, right? So if you are building such chatbot in a closed domain, right, I would say the retrieval-based method is actually the best method, right? Because you don't want the chatbot to improvise the answer, right? So you want to be, the pinpoint to the answer. If it's there, then please just direct me to there. Don't just freeze it in a very improvised way. I don't need creativity there. I need my answer, right? So this is a very good for closed domains, such as the chatbot, the doc bot that I will show you later, and also the customer service, right? The customer service, when will my food arrive, right? So, and how long does it take to get my money back if I just refund some articles, right? Refund my things, right? So those kind of things are usually closed domain, right? Because they already have a database which contains all the question and answer. And for some domains, right? So let's say companion bot, right? So yeah, I have a mother in China, which she's feel very alone. She needs some companion and to talk with her. But because I'm in Germany, I'm in different time zones, so sometimes when she wants to talk to somebody, nobody can talk to her, right? So for those kind of chatbot, you don't want to be restricted to certain closed domain. You want this to be creative. You want this to be improvised, right? So I would say the generation-based measure is more suitable, more feasible to that domain, right?
Mm-hmm.
So those are just my understanding about the difference on these two approaches. Yeah.
Interesting. So in this case, you would need a huge text base to feed the neural search engine, right?
Yeah.
Mm-hmm. Okay, thanks.
Yeah. Yeah. All right, so let's continue. I mean, we can talk to the chatbot things later, right? So I do have examples about that. So let's just summarize, right? So before we just go into the next engineering things, right? So it's very scary for a lot of people, right? So let's just hold here, right? So let's look at what neural search can solve, right? In one sentence, neural search can solve all the symbolic search cannot solve problems, right? So basically anything beyond text search, right? So whether it is image to image search, video to video search, audio to audio search, right? So those I consider as a multimodality search. And there are also like a cross-modality search basically means that the input query and the retrieve documents are different modality, right? Different data types, right? So let's say you want to search, your input is a video, image, and then you want to search for the sun, right? So let's say you take a photo of the ocean, right? And then you want to get some music, something that related to the ocean picture that you just upload, right? So I mean, it is again not a made up, applications. Look at the TikTok. Right, look at TikTok. Look at their video editor on mobile, right? On mobile, in-app video editor, they already have such functionalities, right? So basically, it allows you to take a video, and then it automatically search for suitable audio clips, right? That fit into the atmosphere, fit into this environment, right? So this is cross-modality search. Right? Okay, so now you can see that in order to enable those very advanced search scenario, right, search applications, you need to use deep learning, right? So that's where the neural part comes from, right? The neural, that's why there is a neural in the neural search, right? Because you have to use deep neural network to enable the search, right? All right, so as I said in the beginning, right? But isn't that just encoding? Isn't that we just use Hugging Face transformer and transform something into the vector and that's it? Isn't just the problem solved, right? It is not, right? Otherwise we won't do this as a company, right? Otherwise the search is, a lot of companies, a big or small company, they're working on the search, right? Because if you think about the encoding, the representation learning, of course, it is the most obvious part, right? But it's not the full story, right? As I said, search is a big pipeline, right? It contains upstream and downstream, right? You want to make the system perfect, you have to make every part of the system, subsystem also perfect, right? And what are the fundamental problems there? So why aren't neural search like extremely popular today? Right, if it is the trend, right? So there are some fundamental problems. There are many problems, right? I just list a major 4 problems, for you to scare you, right? And the first problem is how do we quantize the semantics, right? I mean, if I asked this question like 10 years ago, then the answer could be very different because back in 10 years ago we were in the dark age of the shallow learning, right? where the light of the deep learning is not, shining upon our head, right? It's a dark age of the shallow learning. Right? So back in the days, we were talking about, using word2vec, globe model, or sometimes even, TF-IDF, just a count histogram, all this kind of stuff. But right now it's simple. Just feed that into the deep neural network, right? So that's problem solved, right? So, but that's of course not that easy in practice, right? So, but just this is the first problem: how to quantize the semantics, right? How to get a vector representation of your docs. Okay, so now the second problem is once I have the semantics, right? So this kind of semantic representation, how can I store them? Do I store them in MongoDB? Right? Do I store them in a MySQL database? Or how should I store them? Right? And then you immediately realize that, oh, it's like a NoSQL database, but the key value, the value part is a little bit different, right? It's not like a JSON string, it is an ND array or NumPy, right? So how do you want to effectively store that, right? And retrieve that, and then query that? Probably you need a new type of database, but I don't want to exaggerate on that, because from what I've seen, most of the operations, most of the query language that you query against such vector database is basically dot products, right? Unlike SQL database, right, where you have all this Boolean expression combining, XOR this and all this query combining together. Unlike that, the query language, remember this word, this sentence, the query language, the query against a vector database is dot product, right? It's just a dot product, right? So in that sense, you probably need a vector database, but in the end, it's some kind of dot product, right? But it's just a matter of speed, right? Okay, so finally, the third question is, how do we define similarity, right? So let's say we have two vectors, right? We have these, not necessarily just vectors, it could be tensors, right? So let's don't be very, don't just restrict ourselves. It could be the representation, could be a tensor, right? So let's say we get some tensors, right? So ND array, right? So how do we compute the similarities here, right? So from high school, we know there's cosine, Euclidean distance, and then later we learn there's even more distance metric, like whatever this Manhattan, this kind of things, right? But right now we also notice that you can use deep learning, right, to build such metric function, not necessarily to predefine some mathematical metric function. You can learn such nonlinear metric function to define your similarity, right? Okay, and the last problem is something that always be ignored by a lot of people is the granularity, right? Or generalization ability of your model, of your source, of your system. So, so how to understand that? So basically, my argument is that if you want your search system to be at the best performance, then your input granularity should be more or less the same as your output, as your document granularity. So how to understand that? So basically, it means that if your input is a picture of 64 by 64, then it's better that your retrieved, your database, image database is all something image like that, right? Like 64 by 64, and maximum like 100 by 100. Don't be like that. Your input is like a 64 by 64, very simple image, just like a single panda, right? And then your image database is like a very complicated database, like everything, right? Like a city landscape, all this like the people on the street, a very complicated thing, and it's very high resolution. So this is kind of like an incompatible granularity. The same thing also happens when your input is a short query, but you want to retrieve a long document, or your input is a long document and you want to retrieve a short query, right? So the reason behind that is also very, very straightforward. So let's say you want to use deep neural network to encode, right? Let's say we use BERT, right? Google BERT model. And then we input a sentence of 512 tokens, which is the maximum that BERT can support. and it gives you vectors in the end. And then there's another example where you just input hello world into a BERT model, which also gives you a vector. In the end, these vectors are all 768 dimensions long, right? So that's how the BERT looks like, right? But which one do you trust more, right? So is this like a 500 tokens paragraph you feed into BERT and they squeeze into one 700 dimension vector, or it's like a hello world, 2 tokens feed into BERT and then output the same length vector? Which one would you trust more, right? So that's a question, right? So that's a question. That's where you see that why when people actually doing search, right? So there are a lot of things that need to be considered, right? And that's why if you just say, yeah, I can use Hugging Face, right? So that doesn't mean anything, right? Okay, so anyway, so let's end this. Let's take a pause, right? So we talk about neural search. We talk about neural search is about using deep learning to solve the search problem, and search problem is not that easy. It's a super big pipeline, and then you have to use deep learning here and there, and to re-innovate, to rethink, to challenge yourself about thinking the whole pipeline. Okay, so that's the AI part, right? So now comes the scary cloud native part, right? So which is very engineering like. So I don't want to be very elaborative on these things, but I just because I'm also now in background of this kind of software engineering, as I study Ph.D. As my Ph.D. So I'm not like a cloud native expert, right? So I don't do like a hardcore software engineering things, right? All right, so here's a quiz again to warm up you a bit, right? So these are the 4 libraries like TensorFlow, PyTorch, NumPy, and scikit-learn, right? So it's a multiple choice. Which one of them is cloud native? Right. So yeah, I don't know in how the definition of the multiple choice, but back in the days in China when I was in high school, the multiple choice also means no choice, 0 answer, right? So in this case, none of them is cloud native, right? So none of them is cloud native. So why do I say that none of them is cloud native? Because there are like 4 or 5, let's say, pillars or elements that define the cloud native, right? So cloud native is not a single technology; it's a kind of like a family of technology, which if you check mark every item in this family tree, then you can claim yourself as a cloud native, right? So like microservice, containerization, DevOps, orchestration, and CI/CD, right? So those are the some people put orchestration in that, some people put CI/CD in that, but those are the 4 or 5 terms in that defines cloud native, right? And then if you look at all this deep learning framework or machine learning framework, none of them is really microservice or you heavily use containerization, right? Underneath, right? So this is basically why I don't call them cloud native. Okay. So now let's talk about why do I marry this neural search and cloud native together, right? So what's the combination? What's the touching points there, and how do they even relate it? Right? How do they even relate it? Okay, so remember, I have said many times that neural search is not a single task; it's a pipeline, right? It's a pipeline, right? And think about the cloud native part, right? So microservice, right? You have microservice that serves a subtask, right? And then in the end, you orchestrate all the microservice into some kind of pipeline and workflow to solve the big problem, right? So in that sense, it is very close. It is very similar, right? And then, and also one thing about neural search is because we use deep learning libraries, right? It always involves some very complicated package dependency, right? So let's say it works on TensorFlow 2.1.6, but it doesn't work on 2.2.0, right? So basically, every time when people try to repeat or reproduce your result, he or she has to, fix the TensorFlow version to the exact same version, fix the environment, CUDA to 8.0, not to 7 point something, right? Fix all this driver, the dependencies of the environment in order to reproduce something, right? If we look at the cloud native side, the containerization actually very well solves this problem, right? The containerization basically protects the software, protects the logic by a very stable and immutable environment, to support that. So containerization is a solution to solve all this complicated environment setup, right? And finally, as I said, right, so neural search in the future will become a very common infrastructure technology, right? It will become so common that every app will need it. Every app will require it to be as stable as it can, right? So therefore, the DevOps and CI/CD must kick in, right? So now you can see that this three, but there are, of course, other similarities there, but I just list this three. And then you can see there's strong correlation between them, right? And that's why we have Jina today, right? That's why we have Jina as from its branding, its cloud native neural search framework, right? And you can go to GitHub and then just look around, right? Don't forget to give a star, right? And try give a star fork or whatever, right? Yeah. So I mean, what is the highlight of Jina? And I would say, as I said, right, Jina is kind of the son of the Genus system, so it aims to be universal on all data types. Right? It aims to be universal on all data types, and it's a very fast and cloud native. The most promising things that I see by using Jina is saving a lot of time, right? It's saving developers a lot of time, right? So how do I understand that? So if you think about this, right? So when we think about computer science, so every age or every era, right, has kind of like a programming language or design pattern of that era, right? So in the old days, you have the C and Fortran things, and nowadays you have Python, Rust, Go, this kind of high-level language, right? And if you ask people to develop a game, right? So then people will use another high-level language instead of going to C, to program everything from C. Of course, you can argue that C language is, of course, very fast, very efficient, very hardcore, and that you can basically program everything from C. But don't forget that when you build a software, you aim for its sustainability, right? You hope that the software can live longer, right? Can live forever, right? So this is the best, right? And but of course, like this software, especially when you work, when you build a big system, it's not just about you, right? So you can say, oh, I will just hack this thing in C, right? By drinking a cup of coffees and then stay up, for couple of nights, and then I build up these things, right? But what about the readability there? Is someone going to maintain your code, or is it just purely your job, right? So in practice, in the company, usually you have to work with other people. And other people might leave the team, might leave the company, right? But the software has to be there. The software is a property of the company. It has to go, keep going, right? It has to be there. It has to be sustainable, right? So the first priority of building a software is not about, hacking it. It's about its sustainability in the long term. If you really want to build a serious system, right? And you also want to save human time, because human time is so precious and computer time is not, right? Computer is like a computer can live forever, right? They can live longer than we do, right? So why do we have to save their time, right? We have to save our time, right? And so when you use Jina, you kind of have a feeling that, Jina provides a framework. You can say a framework, or you can say a boilerplate, which allows you to focus on the real important problem that you should working on, right? and just hand over, or delegate all the engineering things, cloud native things, all this design pattern things to Gina, right? They will just take over that. So that's about the saving time part. And finally, I would say one of the proudest things that we have is, Gina has a very lean dependency, upstream dependency. Of course, like every software has some upstream dependency, right? So just a matter of big and small, right? More or less. Right? And Gina only have 5 dependency on its core, right? So like a protobuf, numpy, gRPC, 0MQ, and there is a YAML parser, right? So that's a very essential, dependency that we cannot eliminate further, right? And by having that, by saying that, all the other part, including the orchestration, including the network layer, the data types, all this kind of thing is developed by ourselves, right? So that basically help you to own your stack, technology stack. And instead of just glue all the technology stack together to build a very fragile solution. By using Gina, you can build a very stable solution that can go with you, right? All right. So that's basically the highlight of Gina. So we will come to the architecture later, but let's first look at the, very basic fundamental concept in Gina, which basically, I in the documentation I said that this document, executor, and flow are the three only things that you have to know. And once you know them, you know Gina, right? You know how to use Gina, right? So to understand that, yeah, by the way, we'll also draw some cartoon characters, to show how easy it is to understand those guys. Right? So document, let's start with the document. Right? So document is a basic data type in Gina. It's basically like NumPy. It's basically like ND array in NumPy. It's like a tensor in TensorFlow. Right? It's a kind of like a primitive data type in Gina. Right? And then we have the executor. So executor is the, how Gina process documents. You can consider it as a logic unit, an algorithm. It basically takes the documents and input, and then takes a document and outputs documents, right? So this is executor. And finally, we have the flow. Right? The flow is basically concat, streamlines the executor, and distributes the executor to accomplish the final task. Right? So let's take a look. This very simple hello world examples, which basically very well explain how Gina works, but it's very simple, very minimal. So first of all, we have this document, right? So in this case, we just want to set up the flow and then print the document, right? Hello world, by using the executor. So we build a document called document text equals hello world, and then we write an executor. It's very simple. It's just a subclass from the executor class, and then build one thing called my executor, and you have this full function, and then you receive the documents and you print it, right? And finally, you put this executor into your flow by using the add, right? And then you open the flow as you're using Python file. You open a Python file. You just with F, let's open the flow, and then post this document into the flow, and that's it. So in the end, you get this output. Right? So it's basically saying that, oh, everything is ready, and here is your document. Right? Of course, you already see that there's some crafty things going on there. So there's a protocol gRPC, and there's local access, private network, all this kind of things. Basically telling you that Gina is cloud native. Right? Basically, by running this script, you actually set up some microservices underneath, right? And then it basically, all the computation, transmission actually happens through the microservices. Right? Okay, so let's look at these three. So this is a general idea. So let's look at these three fundamental concepts and how does it work in Gina, right? So let's first talk about the document. So document, as I said, is ND array in NumPy or TensorFlow or the tensor in TensorFlow, right? So in Jina, document can contain anything, like from video, audio, images, ND array, blobs, binary buffers, all this kind of things. They can be all stored in the document, right? And document in Jina can be also nested, can be also recursive in both directions. So you can basically say that, oh, there's a match of the document, which basically considers as neighbor. And there is also a children of the document, basically consider as you can consider the sub-document as a children of the document, right? And this recursion in both horizontal and vertical way can go forever, right? Can go, forever. And then this becomes a very powerful representation of the document, right? Think about it, like, let's take a real, I mean, a lot of people are asking, well, is this over engineering, right? So do we really need this kind of recursion, on both directions, right? So let's think about a book, right? A real world object, a book, right? A book is composed by a lot of chapters, right? So you can consider each chapter as a subsection, as a sub-document of the book, where book is a mother document, right? And then for the chapters, then you can cut into section, and section is the sub-document of the chapter, right? And then for the section, you can cut into the paragraph, or you can cut into page, and you can cut into paragraph, and then until eventually you cut into token, right? Sentences in token, or even letter, character, right? So this is how you build in the vertical directions. And when you think about search, right, you can say, yeah, I want to search this book against other books, right? So this is usually happens in the recommendation system, right? So you have a book, and then you want to search, the search results should be matched on the top level, right? So you have a book, and I want to see what are the other popular books that are kind of in the same category, right? So this is a book-to-book recommendation or book-to-book search. And then you have chapter-to-chapter search, right? So basically to compare, to analyze the book structure, all these kind of things. And then you have the sentence-to-sentence search, basically to usually to check whether you have copy other authors' article without giving them credit. Right? This is a kind of applications, paragraph checking, sentence checking, all this kind of things. Right. And then you also have, of course, when you want to search internally inside the book, right? There's some different granularity, right? So you probably want to search for keyword, you want to search for sentence, and then you want to search for, for table, for image. So it's on different granularity. So that's why you see this is useful. So this is about text, right? Text is very easy to understand. How about other modalities? How about video? Right? So if we take the top level document as a video, right, like a 45 minutes movie, right, then what is the sub-document there? Right? A sub-document could be, the video also has some narrative. You can cut into every 10 minutes, this kind of storytelling logic, right? You can cut this by that, right? Or you can say that, I don't know if you're familiar with a long camera. Right, so long camera basically means that you keep the camera without changing the without suddenly changing to another scene, right? So you always keep the camera going. So without cutting, basically without cutting in the middle, right? And you can also use some heuristic to detect the shot, to detect the boundary of the shot, and make each shot as the sub-document, right? So this is also one way to build hierarchical document representation of video, right? All right. So and then the other very interesting kind of like extended document object document type is called document array, right? So if you say that document is like a float or integer in Jina in NumPy, then document array is like an ND array in NumPy, right? It's kind of like the list of documents, right? And here we can do all this kind of, the match function, you can compare the document array against another document array and found the top K documents in this document array. You can do the match over different traversal. You can on different levels, on different granularities, on both horizontal and vertical ways. So all the things happens here. We also have a very efficient structure called document array map, right? So this is just a drop-in replacement of document array, but all the computation, all the storage actually happens on disk, not in memory. Right? Okay, so far enough for the document. So let's move on to the executor. Right? So executor, as I said, is the algorithm. It's a logic unit of Jina, right? So there we have this is a very simple executor which just print your arguments and then end, right? So in practice, you can use executor to do all kinds of things like segmenting, pre-processing, embedding, storing, retrieving, filtering, sorting, ranking, right? All these kind of things can be implemented as an executor, right? And also like the most exciting part, the AI part actually also happens in executor. Right? So those are the executors, written in different languages. So you can see most of the popular, your favorite libraries are there as well. Okay, so that's the executor. So we will talk about executor later. So we actually have an executor marketplace, which is called Jina Hub. And then if you go to hub.jina.ai, and then you can find this marketplace. Okay, so let's look at the flow. As I said, the flow is the higher level kind of concept, which basically connecting the dots to accomplish a task, right? So that's the purpose of the flow. So in the at its minimum form, you can just add executor into the flow, right? Just like this. So if you write flow.add, so this will basically chain two executor together. Right? So in this case, because you don't give any executor, it will just add an empty executor, right? Like no op, it doesn't do anything. And you can also build flow using MNIST, this kind of keyword to somehow build the parallelization inside the flow. And then you can also parallelize inside each executor. Right? So this will, this will immediately scale out your executor into 3. Right. So the flow is a very powerful, let's say orchestration layer, and we can also visit the flow. We can also talk to the flow by using different protocol. But here by using different protocols. So you can use gRPC, you can use WebSocket, and most of the time when you deploy a flow, so you can directly talk with it via HTTP, right? The flow can be also run. So each executor in the flow it's not necessarily local, right? So as I said, Jina is a microservice architecture, right? So each component, each executor can be run either locally, remotely, inside Docker, remote inside Docker. Right? So you can just simply do that by just giving some keywords in the arguments. Right? Okay, so there are also when you deploy the flow, you can also use in 2 different ways. You can use a flow as a file, right? So as you open a file, or you can use flow in a very explicit customer, client and server structure. Right? Okay, so having talked about all of this, so what exactly does Jina provide? Is this just some boilerplate, or is this some MLOps things? No, it isn't. Right? So let's look at the infrastructure. Let's look at the layers that behind, the Jina framework, right? It comes with 7 layers. If you zoom in, if you look at the source code, it comes with 7 layers. So let's look at the animation again. It starts from the basic network and computation layer as a foundation, and then we come to the data types. This is basically the document or document array I was talking about. And then we have the logic layer, which basically consists of the executor, right? A lot of executor. And then on top of that, we have runtime, we have microservice, and we have the orchestration, which corresponds to our flow layer. And finally, we have the application, which basically is the thing that you're working on, right? So is that over engineering? No. So I will argue that eventually, right? So if you don't use this kind of architecture, this 7 layers, right? Eventually, your system will become something like that, right? Eventually, will become something like that. So what Jina provides is it knows that eventually your system will look like that in terms of architecture, but we don't need you to learn all of them. You only need to learn 3 things, right? The data types, the logic, and the orchestration, right? That's enough for building your neural search applications. All the other things, we make them invisible to you, right? We make them invisible to you, so that you can focus on these 3 things. And these 3 layers basically correspond exactly to the flow, to the executor, and finally to the document or document array, right? Okay, so that's so much for the for the interaction, for the architecture and high level things. So let's look at Jina in action. So let's first solve the problem of finding the fashion images, right? So we have the images there, and then we want to use as I said, we want to find a similar image in the database. How do we solve this problem using Jina, right? So here I just build a simple encoding service. It's very simple. It's basically using SVD, singular value decomposition, right? Because for such simple data set, for such simple image, you don't have to use deep learning, right? So it is so simple that you can do random projection, project into a fixed dimensional vector space, and it usually gives a very good result already, right? So here I write a simple singular value decomposition, and then found the the principal vectors, and then project that onto the on the principal dimensions, and then I get the 50 dimensions representation of each image, right? And then the second step is to store this image as well as their meta information on the disk, right? So here I just use the document array map, and then I open it as a file, and then store that on the disk. Then finally I set up the flow. As so look at this. So the first I build an encoder, which is an executor, and then I build an indexer, which is again an executor. Finally, I connected 2 things together. I even add a small tricks here to add the parallelization, because I think the encoding part may take some more time. So as I want to parallelize it, I just parallelize it by setting this to 2, right? And finally, I open it as a file, right? And then input your data into that, and that's it, right? That's it. So in total, you can see that I didn't use any third-party library. I just used Jina, right? And also I didn't use any let's say some kind of pre-built a model from Jina. I hard-coded, I handwritten this model by myself. I handcrafted the model by myself. But even then, right, writing the whole solution end to end, only takes you 50 lines of code, right? 50 lines of code in total. So that's basically the time saving that Jina can give you, right? And this after 50 lines of code is not something that it's just a toy example you cannot deploy. You can deploy already, right? So you can directly serve flow to the outside using HTTP, and then you can query it, you can scale it, right? However you want, right? So that's why we call it a cloud native or cloud ready solution, right? So let's look at another example about the code search. So here I want to build a fuzzy, kind of like a fuzzy version of grep. Right? So grep is a tool in Linux or Unix system where you can just search for text, search for text by keywords. Right? So here I want to build a very similar thing, but kind of put some fuzziness or semantic things into the grep thing, right? And this is a 29 lines of code, right? So let's say 30 lines of code. The interesting part is if you just copy paste this code and run it, it will search for itself. It will search, it will give any input. It will find the most similar lines among those 30 lines of code and then output the results to you. Right. It's like a snake. It's like eating itself. Right? So that's very geeky part of this kind of example, right? So let's look at this example. Right? So let's look at how does it work. Right? So first we build an encoder, which is basically a character embedding. Right? So here I don't want to over-engineer. Right? So if I don't want to use BERT, then I don't need to use BERT. Right? So here I just build a very simple character embedding by just counting how many letters do this sentence have, right? Does this sentence have? And then put that into the histogram, right? The second step is again to store the embedding using document array map, right? And then later, I set up two endpoints here. One is for indexing, one is for search, right? So later that I can search for, query this endpoint, I get the result. And then finally, I set up the flow, right? And then put data into that, right? And after it's done, I just serve it, right? So that's it. So 29 lines of code, and then you get a simple fuzzy version of the graph, right? And it's ready to deploy. And you see that basically, when I tell that, a lot of people think about, today's machine learning framework should be a one-liner, right? So, but if you think about the, framework like Jina cannot be one-liner theoretically, right? So it's just a multiple layer of abstraction, right? When I look at a framework, a software, a machine learning, deep learning framework, when I look at whether it is good or bad, when I look at the readability, I look at the source code there. I look at if I just read the source code, can I understand it? If I have no experience about Jina, if I just have I'm just a very professional Python programmer, right? I don't have any experience about Jina, about TensorFlow, right? If I just look at the code, can I understand that? If the answer is yes, then I will say the framework is doing a very good job, right? Because the framework should not give you an extra burden on learning things. It should help you to do things much faster rather than just, in order to do things faster. So first of all, you have to spend 3 months to learn this, right? Then this is not a good framework. So look at the code here, right? Even though on the second line, we import from Jina, import document array, executor flow request, right? So you look at all the API, look at all the computational part, storage part. So all this is very natural. It's very straightforward. There's nothing that you need to pay attention to understand, right? Okay, I think my microphone just goes down, so I have to use the the laptop microphone. So I hope you can hear me. Oh no, you cannot hear me.
It's working fine, and I can hear you clearly. No worries.
Loud and clear.
All right. Okay. Yeah, so that's it. I think that's, I was going to talk something more, but in general, so that's the presentation, right? So I think we can, we can pause it here a little bit and then see if we have some questions.
I think you have been so rich in information, so basically we have no questions left. So that's fascinating. But I think it was because you were very clear in the structure, so I was following it myself. And I said, okay, that's I got the point. Maybe some practical questions, Alex, since you're also managing the community. How get people started?
I would say, first of all, can you hear me?
Yeah,
yes.
Perfect.
Oh, perfect. First of all, visit our GitHub repo. It'll tell you everything you need to know. And then if you want to get involved and you have questions, go to slack.gina.ai. You can join our community right there. We've also got a bunch of Hello World examples. And if you want to see things running in your web browser with no muss, no fuss, go to examples.gina.ai. We've got a meme search engine. We've got an App Store search engine. And yeah, soon we're going to have a whole lot more.
Okay, awesome. So for Slack group, if you can post it in the chat, that would be nice. Just a link to it, that would be interesting. And yeah.
Oh, exactly. And we've got an exclusive event coming up very, very soon that, you know, you wouldn't want to miss out on. So
okay.
Go there, slack.gina.ai.
Okay, as you said, you're driving us crazy, right?
I mean, it's just what I do. It's my pure animal magnetism.
Animal magnetism, yeah, perfect. Okay, awesome. No, I found it interesting. I am actually thinking of maybe test it myself, using it as a search engine for us. What kind of minimum infrastructure do you need to run it?
I would say Linux or Mac or WSL2.
Yes.
We do have, we're testing support for Windows. It's in beta, I think, right now. I mean, use a virtual environment because you don't want to screw everything up. I mean, Han was talking about dependency management and yikes. But I mean, that's pretty much it. I built the meme search engine. I have no, well, okay. I don't really have good experience in deep learning. I mess around. I don't really know what I'm doing. But I could build this with, I didn't even write any of the executors myself. I use stuff from, Han, can I say it? Yes, I use stuff from GitHub, which is the app store executors, which you don't know about that yet.
Okay, okay. But we have at least a link to have Jina AI, yeah? So we can...
Oh, yes, so you spilled the beans already.
Yeah, sorry for that.
Oh, wow. It was going to escape sooner or later.
Okay. I mean, the good thing is that this is all virtual and can't grab me, right? Okay.
Well, that's true so far. I mean, yeah, when's the next flight to wherever you are? Oh, I think we've got a queue.
I got a question from Craig. I just invite him to the audience here. Craig, can you hear me?
Oh, hi, and thank you for the very nice presentation. I missed a part. I hope it has not been answered already. So my question is that let's say that I have a repository containing audio, video, and textual data. Let's say multimedia data from concerning news about events that are coming from Twitter, from all over. Can I use, are there some pre-trained models that I could readily use via the Jina Hub to index all this in the same space and then be able to do cross-modal queries? That's my question. Thank you.
Yeah, so that's a very good question. Yeah, that's a very good question. So whether you can, so let me repeat the question again. Right? So the question is, let's say we have a BERT model that can work on the text. And let's say we have a VGG model that somehow pre-trained VGG model that can work on the image. But I don't have a cross-modality model, right? I don't have a cross-modality model. Can I just leverage these two models in each separate modality and then somehow magically combine them and then using Jina to enable cross-modality? Is that the question, Greg?
Yes, exactly. So my end goal is to be able to, for example, send an image and retrieve whatever audio, video is similar. So, yeah. So yes.
Yeah. So right now, so we have some models. We have a click model, which basically is majorly working focus on the cross-modality search, whether it's image to text or video to text, all these kind of things. But we are also working on some other secret project, which basically can, let's say, glue glue all these models to build a Frankenstein, this kind of things, right? So you want that, so let's leash the monster. So, but this is actually not, so if you think about this, right? In the end, you want to have these two modalities project into one latent space, right? So that you can search over this one latent space. Right?
Interesting.
Yeah. So in this way, right? So you can consider the model could be just keep original as it is, right? But on top of that, we add some head, right? We add a small head, which basically crosses two models, right? And this head is, you can consider as a simple as multi-layer perceptron, right? Basically, your BERT model output a 700 dimension vector, and then your ResNet output a 100 dimension vectors. And then your multi-layer perceptron takes the input by concatenating these two things into one vector, and then build some layers on top of that, eventually projecting everything into one semantic space, right? So this is a one way. Theoretically, it sounds reasonable, right? So if you do some PhD defense and you throw this answer to the professor will say, yeah, it sounds reasonable, right? But then how do you do that in practice? The most important thing is, where do you get the feedback? Where do you get the training data? Right? Where do you find this association between the image modality? Where do you get the alignment? The alignment is always very important thing when you think about the cross modality. Right? And so fortunately, again, this alignment could be, again, powered by pre-training, right? So you can have some, let's say when you build a video to text or image to text data, so you can use the video subscript, as a kind of the alignment to that image, right? And then build this, based on the video script. So this is one way, right? In general, I would say, if you look at all the Gina products, whether it is about right now what we have in Gina core, or whether we have in the future, and also like currently we also have Gina Hub, and whether the new product in the future, if you look at all the things that we have, is heavily influenced by the idea of transfer learning, right? Heavily influenced by the idea of transfer learning. The reason is that I don't believe that you need to train everything from scratch. What I don't believe is that you have a strong and universal requirement of using pre-trained model and make sense of this pre-trained model in your own domain. This is what I believe. And this is why I built the company in such a way where we don't offer a training from scratch framework or training from scratch tooling, because I think this is job for TensorFlow or PyTorch. Right? To be honest, it solves this pretty well, right? So, so if you look at like all the machine learning engineers, they're basically using PyTorch or TensorFlow for building something from scratch, right? But what about the next step? What about, once you get a pre-trained model, how do you fine-tune such thing to make sense this pre-trained model in your own domain? This is a gold question. This is let's say it's a 1 billion, how do you say that, Alex? It's a 1 billion question of this age, right? $1 million
question.
Sorry?
The $1 million, the million euro.
Yeah, exactly, $1 million question of this age, right? So if you can solve that, right, then you are doing the right thing in this age of AI engineering. I mean, this is my personal opinion, right? So I won't give you $1 million.
Answer the question, save the world.
Yeah, but if you think about this, right? Think about the idea of, I mean, probably, Greg, this is beyond your question. Like, I mean, so it's pretty late. So I was kind of, my brain goes crazy right now. But anyway, so if you think about, from the training from scratch, right? And then you get a pre-trained model, right? And then you have the pre-trained model, you access the pre-trained model and you make sense of the pre-trained model in your own domain. Think about this whole chain. So the TensorFlow and PyTorch solve the first problem, solves the cold start problem, where you have nothing and then you build a deep neural network. Right? This is a TensorFlow and PyTorch job. Yeah. Once you have this pre-trained, once you have this first model, so you have, let's say it's a pre-trained model, how do you make this pre-trained model accessible to everybody, right? And there's one company has already solved that pretty nicely and successfully. It's basically Hugging Face, right? Or Enemy, yeah. But yeah, yeah, Frenemy. But anyway, so this solves this very correctly because we realize that, people, not only AI engineers, but today and in the future, the common developers have a one universal requirement, a very strong requirement, is to get this pre-trained model in an easy way, right? Think about the days before Hugging Face, where you want to find a pre-trained model. You basically have to go to, university website, a Microsoft website, Microsoft Research, Google Brain, and then go to their HTML page, very old-fashioned. You download a zip file and then decompress it, set up all the hardware, and then look at the paper to how to reproduce, set up the environment. And the best part is if you switch another computer, you have to redo this thing again, right? And then with the Hugging Face, right? So you basically can just import Hugging Face from a Hugging Face, import BERT. And this solves all the problems that you have, right? So this is, if you think about this, it doesn't look so complicated. It's not really about machine learning, but it's such a strong and universal requirement of this age that people will have, right? The developers will have. They want to get the pre-trained model by just using it as like an import library. Hugging Face solves this problem very elegantly and nicely, and that's why right now they are really popular, right? But fear not, right? So that's why we built Jina, right? Because this we're all ego, right? In some perspective, right? And yes, so
ego? No. Certainly not.
Yeah, so I mean, in our sense, most of the people will face the second problem after they get the pre-trained model is how to make sense of the pre-trained model, how to maximize the productivity of the pre-trained model in your own domain. And this is a problem that we are solving. Jina, basically by saying that, by considering that, you already have a pre-trained model. Either it is from Hugging Face or from Jina Hub or from your company, you build pre-trained model. How do Jina can maximize the productivity of this pre-trained model in the neural search domain? Not about others, in the neural search, right? How can we maximize the productivity of your model in the neural search domain, right? This is a problem, long-term problem that we are going to solve, right? So back to the question, to Greg's question. No, we don't have this kind of thing, but I just draw a big picture to make sure that you believe me. This is something that we work very hardly on this. Yeah.
Okay, thank you very much. Thanks, Greg, for just raising the question and putting it into context. Awesome. Looking at the time a little bit, so we spent a long time together. Some are even saying, hey, I could have listened to one more hour. So hey, so look, this feedback was fantastic. Clapping hands, I can see them. And thanks again, Han, and thanks again, Alex, for just joining us and giving us, spending the time with us. And I wish you all and everyone who just participated, just time and take some time to test it. So it's all in GitHub. You can actually use it. So if you've seen, it's just a few lines of code. It's not that much, right? So you can suggest a lot. And give it a try. And yes, I say thank you again for you and for joining us and sharing your insights.